Okay, so question 7. The first thing we need to just do is to plot an hour after we started, so at 10 o'clock, 40 kilometres away from home, that goes here. Straight line to join those two things up gets you 1 mark. Then it says he stops for 20 minutes, so we need a third of the distance between 10 and 11 o'clock, going horizontally. And then he travels until he's 65 kilometres away from home, so that's going to be on this line here, at 10 past 11. That's here. So we get a mark for this horizontal section here, and your second mark from the sloping height up to 65 and 11:10. Up here. His average speed for the whole ride now, we'll be careful here because the number of hours that he took. He started at 9 o'clock and finished at 10 past 11. So to turn 10 minutes into a fraction of an hour. Or we could say that 10 minutes is 10 out of the 60 minutes of the hour, or simplify that, 1/6. So in total he did 2 hours and 1/6. So to work out the speed, we're going to do his distance divided by his time. Distance for 65 divided by 2 and 1/6. Use your calculators, 30 kilometres per hour. 2 marks. Cumulative frequency. So what you're looking out for here is they've given you the cumulative frequency already, so there's no adding up to do this time. For each group, you need to make sure that you plotted at the highest number in the group and up to the cumulative frequency. So my first one, along to 42, 44 and up to 32, 46 and 56. 47, 48 and 56, and then 50 and then 60. So 2 marks for plotting all of the points correctly. Your third mark comes from joining these up with a smooth curve. Notice how I've started at the first number in the group at 40. Okay, over the other side, so to work out the median and the interquartile range, or you can use the graph for this. The median we know is going to be halfway between our data, so 30 people together, we're going to go from halfway at 30. So running along and then straight down, mine's come up as 43.8. Yours might be slightly different, you get a mark for correctly reading it. The interquartile range I've done in a similar way. Gone from a quarter of the way along, so from 15, and then straight down. And then 3/4 of the line along, so 45. And then straight down. And it's the difference between these two numbers here. So for mine, it was 45.6, take away 42.2. Again, depending on how you've drawn your curve, you'll end up with slightly different numbers here, but the right process gets you 2 marks. The key word on this next question is consistently. How consistently the balls bounce. For this we need to use the interquartile range. And the interquartile range because it's a measure of spread which tells us about how consistent data is. Number 9 is a trigonometry question, so label the 2 sides that we're interested in, which is the height of the ladder, the opposite, and the length of the ladder that we got, which is the hypotenuse. Opposite and hypotenuse tells me that I need to use sine, so I'll substitute into the formula. To leave me with the opposite side left on its own, we're going to times by 5 to this side. So the opposite we work out by getting 5 times by sine 64, which is this, or to 3 significant figures, 4.49. 3 marks. Number 10. So you can see my trial and improvement here. There is a mark for a correct value between 2 and 3, so you can see my 2.5 and 2.4 here. You get a mark for 2.5 correct and a mark for getting 2.4 is 15.56. You then get another mark for narrowing it down between these two. Your final mark comes for your final answer. Now I went halfway into 2.425. Because this was too small, we know that the value that we wanted must have been the bigger one of the two, 2.43. Number 11. So to work out the area of the shade of the front, we're going to work out the area of the hole and then subtract the semicircle here. So rectangle is 90 times by 65, which gave us that. The semicircle, work out as if it was a full circle. So pi times by the radius, 22.5 squared, and then halve it to give us this. The area of the shape that's left is going to be the rectangle, take away the semicircle to give us this. To one decimal place, 5054.7. A mark for the rectangle, a mark for working out the circle and then halving it, a mark for subtracting, and then a mark for your final answer. To work out the curved surface area, so this is going to be the bits of underneath here, we're going to need to use this length and then multiply it by the distance that we've got going back here. So first off, this distance here is going to be half the circumference. So we know that half the circumference times by the length will give us that curved area. It's going to be for us a half times by 45 times by pi, which is the circumference, times by the length 20 gives us this answer, or 1413.717. Question 12. Okay, so in question 12, we're going to start by working out what his total score was after 10 innings. We're going to do that by multiplying his average by 10. His total after 10 was 312. Similar sort of thing after his 12th one. A mean of 35 means that after 12 innings, it would be 35 times by 12, which is 420. Now the difference between those two will tell us the total increase between his 10th and his 12th innings, which means that 108 he increased by. Now we know that one of his new two innings was 67. 108 take away that 67 leaves us with 41, which must be his 12th inning. So 41 is the answer. 1 mark for this, 1 mark for this, 1 mark for this, 1 mark for this. Okay, so for the simultaneous equations questions, let's look at this interesting looking equation. So the first thing I've done here is to go through and multiply everything first of all by 4, and then secondly everything by 3. Get rid of the fractions from the bottom here. So on this part here it leaves us with 3x. And we've multiplied this by 3 and then by 4 gives us 4y. And then 2 times by 3 times by 4 gives us 24. So a new version of the second equation, the first one can stay as it is. In order to get the y's the same, I've gone 4 times by 4, which left me with 8x take away 4y equals 20. Now because the y's are the same but the signs are different, we're going to add the adding them gives us 11x equals 44. Divide both sides by 11 tells us x must be 4. Some substitution now, so back to the original equation that we had. 2 lots of x, now we know that x is equal to 4, so 2 lots of 4 we can now swap for 8. 8 take away something has got to be 5, so that something there is going to have to be 3. Y is equal to 3. 5 marks for this. You may well have gone about this in a different order, making x's the same rather than y's, but if we got to the stage here where x is 4 and y is 3, you've got yourself 5 marks.